Hi, everyone. Let's see if you can beat the doctors on this. A medical diagnosis. Let's assume that 100,000 adults live in Fredonia. I'm picking a nice round number here. I made this up. Uh, it's a strategy that you can use to pick a nice large round number in order to base calculations on. It's a strategy. A test exists for the disease Cooties. I did not want to say coronavirus. I want to say Cooties. The following probabilities apply to a randomly selected adult Fredonian. First of all, let's assume that 1% of all adult Fredonians have Cooties. So the probability that a random adult Fredonian has Cooties is 1%, or 0.01. This is the prior probability of having Cooties. The probability that you test positive, given that you have Cooties, is 80%, 0.80. The probability that you test negative, given that you don't have Cooties, is 0.90, or 90%. So let's say that a random adult Fredonian does test positive for Cooties. So this person goes into the hospital, takes the test, and gets a positive test back. How freaked out should this person be if Cooties is a bad disease? What is the conditional probability that the adult has Cooties given the positive test result? So find this conditional probability, the probability that the person has Cooties given that the person tests positive. First of all, what would you guess, just subjectively, based on the given information? What would you guess? You live in Fredonia, you're an adult, you go in, you take a test, the test comes back positive. What's your updated probability that you have Cooties? The prior probability was 1%, or 0.01. You got a positive test. What is your updated probability of having Cooties? I'm taking the Bayesian approach, where you're allowed to update probabilities. So you have your guess. Now, to help figure out the actual probability, using a table, go ahead and fill out this table. The grand total is 100,000 adults who live in Fredonia. Based on the probabilities you see here, assume that these probabilities are perfectly reflected in this table. Fill out the marginals, the row and column totals, and fill out the individual entries. And then figure out this conditional probability based on your table. I'll give you a minute to do this. Go. So now, some of you may be shocked. Others of you might be going, well, I'm not sure what's going on here. Don't worry. Let's work through this. All right. Let's assume these probabilities are perfectly reflected by this table. 100,000 adults live in Fredonia. 1% of them have Cooties. 1% of 100,000 is 1,000. So 1,000 adult Fredonians have Cooties. They go in the yes column here. Which means that the other 99,000 adult Fredonians do not have Cooties. So 1,000 adult Fredonians have Cooties, 99,000, the other 99,000 do not have Cooties. You have this unfortunate 1% who have Cooties out of the 100,000. Now, among the 1,000 people who have Cooties, 80% of them will test positive. So among the 1,000 people who have cooties, we're saying that 800 will test positive, the other 200 will test negative. Among the 99,000 people who don't have cooties, 90% of them will test negative. It might be easier to figure out the 10% that test positive. Among the 99,000 people who don't have cooties, only 10% test positive. That's 9,900. And then I'll subtract to get the number of negative test results among the people who don't have cooties. That's 99,000 minus 9,900, so 89,100. So now, looking at these marginals here, the row totals, how many people total should be testing positive if all 100,000 adult Fredonians are tested? 800 plus 9,900 is 10,700. To a negative test results, 200 plus 89,100 is 89,300. Or you could have subtracted this from this. As a check, you can see that this plus this is 100,000. Also, this plus this is 100,000. All right. Now, when we compute this conditional probability, what numbers do we need? We need the number of people who test positive and have cooties. That's right here. They test positive and they have cooties. I'll put that in red. 800 adult Fredonians should be testing positive and they have cooties, divided by the total number of adult Fredonians who test positive. Remember, it's the number of people who satisfy the condition, testing positive. That number goes in the denominator. The total number who test positive is the 10,700. Put that in blue. All right. Well, what is 800 divided by 10,700 as a decimal and then as a percent? And by the way, what was your initial guess? Because a lot of doctors said something like 75% or 0.75. What was the actual? Again, this is a copy of our table. The number of people who test positive and have cooties is 800 over the number of people who test positive, 10,700. That's about 0.0748 or about 7.48%. So look back at your guess. You may have guessed something like 75% or something like that. That's what a lot of doctors did. Remember, the prior probability was only 1%. A positive test only took you up to about 7.5%. And notice that this probability, the probability that you have cooties, given that you test positive, is very different from this, the probability that you test positive, given that you have cooties. So people tend to be focused on the 80% here, the 0.80, but they should have been more focused on the prior, the 1%, because this is more powerful. Because here's the deal. Let's say you get a positive test. It's much more likely that you fall in which cell? It's much more likely you fall in this cell than in the red cell. Now, if you don't have cooties, but you test positive, you're called a false positive. There were a lot of false positives, 9,900 false positives, relative to the 800 people who were true positives, people who actually had cooties and tested positive. So if you get a positive test result, it's much more likely that you don't have cooties, you're a false positive, than that you do have cooties, that you're, in a way, a true positive. So if you've guessed something like 75% or so for this problem here, for this probability, don't feel so bad. Don't feel so bad. Because if you ask medical doctors were asked this. And on a similar problem, 95% of American doctors said that the answer was about 75%, which was about 10 times the actual percent, about 7.5%. 75% is almost 10 times 7.5%. The true probability was about 7.5%. The doctors were guessing about 75%. They were off by a factor of 10. Now, perhaps you were too, but, well, the doctors were off by a factor of 10 as well, almost all of them. So these doctors, almost all American doctors, were off by a factor of 10. They did a massively poor job on this diagnosis problem because they engaged in what you may have engaged in, which was you engaged in the base rate fallacy. You ignored the prior probability. You focused more on this 80% here. We asked you for the probability of B given A, and you were focused on the probability of A given B, when really you should have been focused on the prior probability. This 1% here, the 0.01, had much more of an influence. People ignore the impact of the prior probability, that 1%. Although the Cooties test seems to do pretty well, these probably seem to be pretty high. 80% of people with Cooties tested positive. 90% of people who didn't have Cooties tested negative. Those sound like good probabilities. They're not good enough to raise this 1% to as high as 75% or something like that. The Cooties test seemed pretty good, but it did not justify inflating the prior probability of 1% to something like 75%. Imagine this scale here from 0 to 1. The prior was stuck all the way down here at 1%, 0.01. That was the prior probability. The prior probability that a random adult Fredonian had Cooties. It was just 1% or 0.01. If you get a positive test, do you go all the way up to here, 75%? No. You just go up to about 7.5%. I'll do this in blue. You just go up to about 7.5%, about 0.075. Now, on the one hand, you could say that given a positive test, so this was the impact of the positive test, given the positive test result, yes, the probability, the updated probability that you have Cooties is multiplied by a factor of 7 to 8. That's one way of looking at it, but it's not multiplied by a factor of 75 or 80. You don't go all the way up here. So the prior probability of 1%, that was hard to raise. Even though the test looked good based on these probabilities, well, the prior was only 1%. It's hard to raise the prior. It's hard to raise the prior. Now, the test was good in the sense that, well, if you're given a positive test, this is multiplied by a factor of 7 to 8, but you don't go all the way up here. So be careful about this. Do not engage in the base rate fallacy. Don't ignore the prior. Only 1% of adult Fredonians had Cooties, and that had a very powerful impact on our result. There were a lot of false positives. By the way, in addition to testing for a disease like Cooties, can you think of other applications? Maybe things like drug testing or lie detector tests. There are reasons why lie detector tests and the results are not really admissible in court as official evidence. Okay, so now you're smarter than 95% of doctors. Congratulations.